welcome everyone in the chat. Obi, you wanted to take
Yeah,
it away?
welcome. Yeah, hold up. I'm kind of behind on the slide. But anyway, welcome everybody. Welcome to our second review session for fall term. In this review session, we're going to cover stacks, lists, and queues. And these are all the array-based implementations of it that you guys have learned in class. And also in this review session, we're going to spend more time talking about examples and going through a few different example narratives to illustrate how these structures work and how you'll actually implement them in code. So, yeah, take it away, Rob, or Safe, whoever.
All right. So basically, let's start with our first. Okay. Yeah, let's start from the beginning.
Yeah, well,
So don't forget to sign in. Use this QR code. Make sure you registered for today's event, and you can add it to your Lorry experience record. Make sure you don't lose your credit for attending this.
yeah, definitely be sure to sign in. For anyone just
All
joining,
right.
we'll give you guys a minute to do
Mhm.
that. I already see a question in chat while we're waiting. Are you going to review priority queue too, or just queues?
No,
No.
we're just doing queues today. We'll
Just
touch
queues.
on priority queues and then probably in the next review session.
That's right. We may be able to answer any questions you have about them at the end of the presentation, though, if you stick around.
Yeah, definitely.
So yeah, I'll just give you guys like another 30 seconds to open that link. For anyone just joining, be sure to sign in. Just have that link open in another tab. All right, I'm gonna move on to our next slide here. Hopefully everyone's gotten a chance to open that up. So this is our current roadmap for our sessions throughout the semester. We're currently at session 2, stacks and queues, looking at the array-based versions of both of those data structures. Sessions 3, 4, 5, and 6 are coming up. I believe our next session, is it the midterm review session, Safe? Is that right?
Yeah. The next one will be the midterm review. Then we're gonna start getting into the linked data structures.
Awesome. Sounds good. So this is where we're currently sitting at for anyone wondering where we are in the timeline. And as far as today's agenda, we're going to be looking at first going over stacks, defining the concept and the concept of data structures and how stacks work. And then we're going to be moving on into queues and looking at how those are different than stacks and, you know, the different implementations of both of those. And lastly, we'll be finishing off strong with the implementation and review of lists. So yeah, without further ado, I guess let's jump into some of our links here and useful resources. If anyone doesn't have these already, we show these in every review session. Definitely note them down, and they're really good. We got chat saying, it says I can't access the Typeform until the creators allows us to. Okay, well, if anyone from events is on stream, could you handle that? Thank you. We'll get an update to you as soon as I get an update. Anyways, here's some of our mental health resources at Laurier. Let's give it a second on this slide. We have the Safe Hawk app, Student Wellness Center, and Delton Gelby Counseling Center. So let's just jump into a quick review.
All right. So if you remember from our last session, we discussed what data structures are, how are they implemented. So there are two main takeaways from this from the previous session. The first is that data structures have the magic of simplifying the process of storing and accessing data. It's not just a giant jumbled mess, actually in a methodical, organized way, which makes life for the user a lot easier. So you as a programmer using the Python programming language, you've already seen certain implementations of data structures that are built in, such as dictionaries, lists, sets, hash maps. But so the purpose of this course is to teach you how to build your own data structure. So if you were to do a lot of tasks without building one, like without having a predefined class or an object, then it would make life so much harder. And thank God, Python makes life a lot easier for us. The second important point is that they provide an easy to use methods. They provide easy to use methods to access and change the data they hold. So you don't. They provide methods and just functions for you to call to manipulate this data. So you can use custom data structures to make your programs easier and to build and have more functionality. All right, so let's get into our first data structure, so which is stacks. So we're going to discuss what they are, how do they work, and why are they useful before jumping into some interactive examples. All right, so what are stacks? As you know from lectures and your labs and assignments, a stack is a data structure where data is stored and retrieved, where the last element inserted is the first element removed. LIFO, or last in, first out. In the real world, you can compare this to stacking plates in a kitchen or in the warehouse. So let's talk a little bit about the warehouse example. Imagine you're in a factory or you're in some kind of warehouse and you're stacking all of these pallet stacks. In order to retrieve one, what would happen if we just grab one from the middle or from the bottom? The whole thing will collapse. So this is a real world application where it's beneficial to go last in, first out. That way, we can keep the integrity of our structure. We can maintain operations within the warehouse and reducing costs, and so we don't have to do a lot of maintenance and picking up fallen pallets. We're going to jump into the kitchen example a little bit later on. Okay, so this is a diagram. You can imagine a stack as just a container, and then you just place the elements on top of each other. So the bottom of the container is sealed, you can't grab them, and the only thing that's open is the one on top. So when you push something in, it goes to the bottom and you can't access it again until there's nothing on top of it. So we push and then we pop from the top because that's the only open part of the container. All right, so why are stacks useful? If you were anything like me, when I was taking this course, I'm like, why can't we just do everything in a list? Clearly, a list, if I just access it from the end of it, I don't need to make a stack. Why does it matter? Which there are usefulness of just using a list. So if you're like an interview question or something like that, you don't have time to write out the full stack implementation. But if you're making a application where you have a user, you want to limit what it is that they can access and what are the methods that are available to them. And that's where a data structure implementation of a stack would come in handy. So in the real world, they're useful in a lot of situations, as you might have seen in the kitchen, Home Depot, or even a football game, where you just have the last person in is the first person out. It's useful in these situations. In programming, they're useful for backtracking, so AKA finding the shortest path at the end of a maze, calculating math expressions that use BEDMAS, so calculating, following the parentheses, putting everything in a stack. That's a really useful application. And when you get into second and third year, you're going to see more applications like depth first search, finding the shortest path. These are all really useful applications of stack.
Yeah, and another good one I just thought of right now too is Control Z, the undo and redo
Yeah.
functions in a lot of
hmm
applications. Those are
Yep.
great uses
Control
of
Z,
stack. Yeah.
copy and paste.
Mm-hmm.
Yeah, definitely. These are another application in the real world that you use on a daily basis. All right, so let's jump into our interactive example. I'm going to share my screen. Can you see my screen? I'm on Replit right now. Can you see it?
Just give me 1 sec. Save to pull it
Oh,
up.
wait, no. First, let's go through the slides first.
Oh, okay. Sure.
Yeah.
Good call.
Okay, before I jump into the interactive portion, let's actually walk through the examples so you know what it is we're doing. So the first example we have is just a basic implementation of a stack. So here we defined our class, And since we're using an array-based stack, we have our data stored in an array called values. This is a private array. We don't want the user accessing this. And to do that, we provide 3 methods for them to interact with the data. The first is push. So the user passes in a value, and then we only use the append method of a list. We don't want the user to access append themselves. We only want them to use it through push, and that's why we make that function. So now, in order for them to use the stack and to add values to it, they can only use push. They can't access the private list. The next method is pop. So a list, the built-in list in Python has a pop method, and don't confuse it with the stack pop. The pop in a Python list, inside the parentheses, you pass in the index you want to pop from. When you don't pass anything in, it assumes the last index. So this is different from a stack pop, which automatically pops the last element out. Again, we don't want the user accessing the private values list. And then the last one is peek. So we want to return a copy of the last element of the list. The reason we use copy is that when you actually just return the value, there's a weird thing with Python where if you edit that value, it'll edit it in the original data structure. That's why we do a copy, to make sure that the value the user received does not interfere with the private list we have in our stack implementation. And then for our next example, so this is an interactive example, our restaurant. So let me paint the scene for you. Imagine you are in a kitchen and you are the dishwasher. And then you have a waiter who goes around picking up dirty plates from the customers and stacking them on top of each other. You see them like with the hand out and everything on top. So imagine all these plates and they're bringing it, and he's bringing it to you to wash it. So you have a giant pile. The way you're gonna start is picking up the last dirty plate first, like the last plate the waiter got and had on his giant stack is what you're gonna wash first. So you need a method for the waiter to add plates, and you need a method the for the dishwasher to remove the plate and wash it, and also to check which plate you're currently on, like you're just looking. Then you use the peek method. So here, as you can see, we are actually using a stack. So we're using the previous class that we defined here inside of a new class. We use the stack, and then we use the methods inside of it to interact with our data. So we're not accessing the private list that the stack has. We're only using push, pop, and peek. All right, and now now I'm going to share my screen where we can walk through it a little bit further. Can you see my screen?
Yeah, one sec, Safe. Let me just pull up your
Yeah, no worries.
screen share. All right.
All right. So I have on me now Replit, where we wrote out the stack and the restaurant example, and we have some test cases. We're going to walk through that. All right. So the first
Safe.
one here.
Safe, you're sharing the Discord on your end.
Oh, I am? Okay.
Yep.
Okay. Can you see this now?
One second, let me pull it up. Yeah, you should be good to go.
All right, bless.
Just if you
Awesome.
can make it a little bit
So
bigger,
the first one
text.
here.
Can you zoom in on the text? Like blow up the text. Yeah, that should be good.
All right. So here we have our coded up class for stack. You've probably already done this in your assignment, but we just want to touch on the fundamental methods of the stack. So here we defined our initial private list, and then here we defined 3 methods: push, pop, and peek. And then here in our interactive example, like in our real world example, we have plates. So you're the dishwasher and you have the plates. So here you initialize a new stack. So this is the data structure. This is the usefulness of data structures, that I can make another stack of washed plates, and that could be a new stack. and these two stacks are unrelated. So the data stored in this stack isn't stored in this one. And that's a really useful application of data structures. That's why we have these classes made in the first place. And now we can interact with this. I'm going to remove this for now. We can interact with the dirty plates that we're given. So the waiter can add a new plate. So that's just pushes on top of the stack. And then I can check which plate I have to do. So I peek and then I see, okay, this is the top plate. This is the dirty one I have to do. I can remove the plate, wash it, and then place it in another stack or whatever. So here in our test cases, we have a waiter. So he goes around, he picks up plate 1, then picks up plate 2, picks up plate 3, 4, and 5. Okay, and here, what we have to do is, so I'm no dishwasher. I just blindly picked up the first plate I saw, washed it, and then now I want to see what the next plate I have to do. So what do you think the plate that we're going to see once we call check plate is? Give you a little minute in the chat to write your answers.
Yeah, we can give it like 10 seconds. I'm just looking at the time. You might want to speed up just a little bit.
All right, sure. All right, so if I already washed the fifth plate and I check which one's been washed, then it's probably going to be plate 4. So let's run it. Yep, as you can see here, plate 4 is the next one on my to-do. So that's the example for for stacks. Now we're going to move on to the next one.
All right, let me just switch back over to our main slideshow here, and we're going to be jumping into queues. So we're going to be covering what are they, how do they work, and why are they useful. Just like stacks, we're going to be looking at the queues. So what are queues? So a queue is a data structure where data is stored and retrieved such that the first element inserted into the first is the first one to be removed. Sorry. So the first one in is the first one out. So we just looked at stacks where our last one in is the first one out, LIFO. This is now FIFO. So just like you're at a line at, let's say, a coffee shop, when you enter the line, and let's say the line's empty, when people join the line, where do they join, right? They join behind you. They join in what's called a queue. So this makes sure that you're the first one served. You showed up first, you're the first one to be served. It's like a first come first serve sort of idea. That's the idea of queues. So that's again FIFO for the terminology side of things. And in an array based queue, it stores data in a private array, only seen within and accessed within the class of the queue, and this limits access to elements so that the person can only access the end of the queue, or so that you could only add and remove from the queue without being able to manipulate the array like you would be able to if it was a normal one. So yeah, that kind of covers a overview of what a queue is, and here is a kind of demonstration, a little graphical demonstration for anyone who's a visual learner of what it kind of looks like. So here's our queue as we start off. We see that we have DCBA, and we have these arrows indicating the direction of our queue. So this is the rear and this is the front. Front meaning the person who, or the object or whatever it may be, that entered this queue first. So the front is who was the first one in, and our rear is who was the last one in, and then the inside is the order at which people or items entered the queue. So here we can see that A entered first, then B, then C, then D, and that makes up our queue of these 4 items. Now, let's say A is a person getting served at the coffee shop. They're next up in line. The next someone just ordered and they're walking up to the cash. So we're going to call DQ is our method for that. And what that's going to do is it's going to now remove A out of our queue because they've now been served. So we're removing from the front of the queue. So this person, again, back to the whole concept of queues, they were the first in, and so now they're going to be the first out. So we see that A leaves the queue, and now our front moves over to B because A's gone, So the next most recent person that entered the queue after A was B. So we can see that being illustrated here, and our new queue is BCD. Now in queues, usually the front of the queue in an array-based implementation is actually index 0, and the back of the queue is the highest index of that list. And so let's get into why they're useful. I covered the cafe example, but let's look at maybe some other things. So they're mainly useful for any case where the first element needs to be processed, such as where the first element in needs to be processed first. So let's say when you go to print something and you're in like an office and there's a bunch of other people trying to print something, it'd be really frustrating if there was a stack implementation to your printer algorithm where only the person that clicks the that clicks print the most recent gets their page printed, and then you could end up, let's say you were unfortunate and someone pressed ahead of you and then more people, and then your request got like buried in the stack. So a queue makes this really easy because you're the first one to enter the queue of saying I want this paper printed, and then let's say the printer has a backlog of people that are wanting to print. They'll join behind you instead of jumping in front of you. Let's say if it was a stack. So that's one application of a queue, and then that also cascades to, like, let's say uploading images or operating systems job processors. So if your CPU is doing something, it's whatever it's told to do first, it'll work on first and whatnot. That's getting a little too complicated. And then you can see later down it'll be used in breadth first searches, which is a little more complicated of like an algorithms type thing, but you will see queues again down the line for those type of things. So yeah, let's jump into an interactive example. Before we do that, we have the little screenshot here. So here's an example of a queue implementation. This is an array based, of course. As we can see, the values is equal to an empty array. We have a couple of functions here to note. We have onQueue, dequeue, peek, and return values. Now, as a quick overview, onQueue is purely for adding a new item to the queue. So we're adding an item to the end of the queue, So we want to add something to the queue, we'll call this function to add to the queue. And then we want to remove from the queue, so we'll use the dequeue function, and this will remove the person that, or the item that entered the queue first. So that's our index 0. And it's a little bit tricky to imagine with the arrays because it's almost like inverted. We usually read left to right, so you would assume that the first person in the line is the person at the far right, or the item at the far right of your array. It's actually not. It's always index 0 in the array based implementation. So that's why you see that we're popping at array position 0 here to remove the first at the queue. And it should also note too that append adds to the end of our array. So if we had multiple items in our array, it would add the value to the next highest index position, and that's kind of why it's sort of flipped. The front of our line is really on the left here, and the back would be on the right if this was a bigger array with items in it. And similarly, peek will take a look at the next, or who's at the front of the queue, or what items at the front of the queue. And then the return values will simply just print off or give us our whole array and what's in it in total. So here's a little bit of an implementation using a queue to create a grocery store checkout belt. So here we are initializing the attribute items as a queue implementing our queue data structure. And here we have a couple of functions that are going to be vital to create our checkout belt, to create a good, useful checkout belt that'll work in a grocery store. So we want to be able to do a couple of things. We want to be able to add an item, remove an item, view it, and also look at the whole belt as a whole, as we can see here. So adding an item to the belt will on queue, so it'll add the item to the queue, and then removing it will dequeue. So it's a simple just a queue implementation here of how it could work in a grocery store. So you add your items to the belt and they get processed in the order that you added them. So that's again the first in, first out um uh I guess what would you call that? I guess algorithm. Anyways, and then we could view the item, next item, and view the belt. So here, if we want to jump into the replit for this one, save if there's one.
Yep. All right. Can you see my screen?
Just 1 second. Just gonna do transition here. Yep, looks good.
All right, blessed. All right, so this is our class implementation of the queue. You've already done this probably in your assignment, so you're not new to this. We have our private list here. Again, the user will not touch this private list. Just like Rob mentioned, we're adding the elements to the right of the list. So we in the enqueue function, we're doing the append. But in the dequeue, we want to remove from the left, and that's where we indicate the index. That's at 0. Peak, same thing. We want the first element, so we make a copy of the first index of the first index of the element. All right. So in our interactive example, so here in the grocery items, we make an instance of uh, our items in our processor belt. So here we make a queue. We don't want to access all the elements available in a stack in a list. So we only have enqueue, dequeue, and peak. So when we want to add an element item, we use enqueue. If we want to remove something from the belt, we use dequeue. And we want to see what the item is, we use peak. And we also made another method called return values that just shows you everything that's in the queue currently. So here we have a couple of test cases. I'm going to jump into here first when I run it. The first one here, we defined our items. We have an apple, orange, and banana. So this is what is in our processor belt. The first one, we scanned the first item. So we dequeued it, we dequeued the apple, scanned it, and then that's been dequeued off our queue. So now what's left in our belt, we have the orange and banana. We scan the next item, so our banana, what's left now, or orange, and what's left now is the banana. And then lastly, when we scan the final item, we don't have anything anymore in our processor belt. So as you can see, we removed items in the order they arrived. Apple, orange, then banana, and that's what we removed.
Right on. So I don't know if anyone had any questions about that. If you do, throw them in the chat.
Mm-hmm.
As I just transition us back here into our slides. Because we're going to be finishing
So
off
now we're
with
moving on to our third and last data structure for today, which is lists. So what are they, how do they work, and why are they useful? You guys have probably all seen a list. It was the first thing taught to you, probably one of the very first things taught to you when you learned how to code. But one thing you should know, a list is not square brackets. There's so much more that goes on behind the scenes, and we need to understand how this works as a data structure. So a list is a data structure where data is stored as a collection of sequential elements, each consisting of a unique index of its position. So for this one, we are using an array to store the data in the list. So it's a list stored in a list. I know it's weird, but that's how your course does it. And you're going to see when we go and link that it works differently. So inside the array-based list, it stores data in a private array that has functions such as append, len, contains, and others for easy manipulation of what's inside of it. The benefit of having a list data structure is that you can keep the original data private. You don't, like we mentioned 100 times, you don't want the user accessing private data. No way. You're gonna learn object-oriented programming, keep them separate. Okay, so moving on now. So here's a diagram of how a list works. So a list is just a collection, it's just a container where you store elements. but each of these has an index. Lists start their index from 0. So as you can see, at position 0 we have 73, position 1 we have 98, position 2 we have 86, etc. And if you want to access them, then you call it at that particular index. So when we have array at 0, we get 73. Array at 3, we get 61. So this is actually a magic method, as you're going to see later on, to be able to access these elements. So the usefulness of lists. Lists are by far the most widely used data structures, as they are useful in cases where you need to store multiple values within one variable, which pops up in almost every single avenue of programming, where you have the same type of data and you could just store them. And you want to store them in one place. They're useful in building other data structures, as you've seen in this entire course. We make array-based. They're useful as a building block for other programs. They're useful as a standalone method or standalone application for you to use. So their usefulness is very varied and encompasses all aspects of programming. Moving into our examples, we have the first one. We're just defining our methods for the list. So we have get item. Before that, we do in our initialization, we store our data in a private array. Our get item, len, and set items are magic methods. So this is a special syntax within Python where you don't need to call that method. So you don't need to do list dot set item. It's just in brackets equals. That's how it works. So here, in order to get the item, we want to make a copy so we don't modify the original data. So you get a copy of the item. For length, you just return the length of that private array. For set item, you set the value of that private array to whatever the user passes in, and then append. So this is a method where we want to add something at the end. So we do the syntax of plus equals, and we also make a copy of the value. The reason we make a copy of the passed in values for the same reason. We don't want to modify the original value that the user passes in. And peek can be done in a different way. Here we just look at the first element like a queue, but you can modify it to look at a particular index. And then we return values to everything in here. All right, so now we have a real world example. So imagine a diary, and so your book is basically a collection of different days. So days, the day of the week or day of the year it is, that's the index. So when we want to add a new entry, that's just making a new page. When we want to view that particular entry, we flip the book to whatever page we want and we peek at that particular day. And then to return the whole thing, then we just return it. And we can implement other methods here, like edit, like delete. These are all things we can do in this real world diary. So in edit, you can just use an eraser, remove the data. Delete, you could just rip the whole page out. And let's just jump into Replit right now to show how it works. So can you see my screen?
Yeah, let me just transition the stream.
All right. So let's have a closer look at our code, like not what we were doing, not just in code, but as an actual application, like screenshot. So here we defined our class. As you've seen, these are all our methods and how we're using them. And inside of our diary, we define the method we want to do. Let's actually do something here where we want to edit entry. Self-edited val. So here just self.entries, and index. So we want to edit it at a particular index. So here at index is equal to edited val. I think it's misspelled. Whatever. But as you can see, we can modify this data structure. We can add new things. We can delete, like, I don't want this view entry anymore. I could just get rid of it. I can add new methods. And we just use the interface of the list class that we defined above. So inside of our examples, we defined our first entries. We just used some lorem ipsum dummy text. So here's the first entry, here's the second, third, and fourth. And if we want to view them or if we want to add them into our diary, so we loop over it and we add them one by one and we view the entries. And then at a particular index, we have diary view at this particular index. Let's run it. So as you can see, this is what we have so far. And at the first index, this is the diary entry. So let's try to edit that first index. So here, so diary dot edit entry, the first one at A, this is a new entry. And let's print it again and see. Yep, so the original one, this is the original one, and then we can edit it again to showcase the new entry in our diary. So we used an eraser and we just overwrote it. The reason why this is useful, I know you might think that, look, I know how to use an array. I've been doing it since CP104. But you need to understand that this is not a built-in feature of programming. You don't know, most languages implement it, but they all did it behind the scenes. They all have their own class that implements these methods for you. So it may seem redundant now, but you need to understand how this works as a data structure to get a better understanding, because arrays are used everywhere. Everywhere you're going to use lists to build other data structures from it. So when you have a deep understanding of the methods behind it and how they're implemented, it'll make your journey as a programmer so much easier and so much better. Yeah, so this is just our example text so far. We could just move over it.
And yeah,
Yep.
we did the interactive example.
Okay, and this, I walked you through our interactive example. This is just the scene. If you wanted to see it, like just the text entry format of it, this is it. But anyways, moving on. Now we've reached the end of our presentation. We reviewed array-based stacks, queues, and lists. If you have any questions, type them in the chat and we'll be happy to answer them.
Yeah, so someone in chat wanted to see the for loop used to dequeue the items from the queue.
Oh, yeah, sure. Okay, so
One sec. All right.
okay. So here, we're actually not dequeuing it, but if you want, let's actually try to go through, let's make a for loop right now and dequeue it. So I guess the first things first, we should probably define a method here to get the length of the, okay, no. Since we don't want to know how big it is, let's use the view item. So as the peak, so here, if as long as peak is not empty, so in here, if in your assignments, you probably had the assert statement, but we can modify it here to just have a, we can just modify it to say as long as self.values, as long as the length of this is greater than 0, then we'll return, else return nothing more to see. So let's implement a for loop. Yeah, so while items on belt dot peak does not equal nothing to see, So while there's still something there, let's actually remove them, because this remove item from belt only does it one at a time. Let's comment all this code out, because we don't want to pop from an empty stack. I'm just going to keep this one here so we can see it. All right, let's try to run this out. Run this. Items in belt. Oh. Oh, no, sorry, it's view entry, not peak, sorry. View item. What is going on here? Oh, this is why. This is why we have the assert statement, so we don't pop from an empty stack or from an empty queue. So basically, if you remember from our assignment, I'll just copy the same code again here. Just so we can avoid it. Oh, yeah, so it prints it out, nothing to see, because now it's empty. Items on belt, nothing to see.
See if I got another question in chat.
Yeah, sure, no worries.
I had a question about circular queues. Since
Oh,
they
yeah.
have since they have a fixed length and you can't use regular list methods like append, insert, pop to manipulate values, how would you go about removing or adding items?
Yeah. So because it's fixed length, if you want to add a value to it, as long as it's not empty, you can do that just fine. But once it's filled up, then you actually remove the first element. So you remove the first value, and then you slide everything down, and then you can add a next one in. Do you understand what I mean? So if it's all filled up, you keep removing the first element.
So you can only ever remove the first, so the front of the queue?
Circular queue. Yeah, you dequeue it. Like if you want to in queue in a already filled up circular
Right.
queue, you dequeue it first, and then now you freed up one slot, so you can add it in again.
Right. Hopefully that answers your question, chat. If anyone else has any more questions in chat, feel free. I'm just going to switch the slide. Awesome. Well, thanks
So how many
again.
people watched this in total?
I don't know. We could look at the numbers after, but till then,
Not many.
thanks everyone for coming out. If you're watching,
Yeah, thank you.
If you're watching the VOD, then shout out to you. It doesn't look like anyone's left in chat here, so if anyone's still watching, thanks for coming out. As always, catch us at our next session, which I believe is the review session. Yeah, take care. Good night.
Good night, everyone.